After 8 days hidden behind the sun, something re-emerged on Halloween that has astronomers questioning everything they thought they knew about visitors from other star systems. The numbers don't add up. 9 separate anomalies, each one statistically improbable, all occurring in the same object. At what point does coincidence become impossible? And there's something else. Something that makes theoretical physicists whisper in private conversations they won't repeat publicly. This interstellar traveler arrived precisely when Earth couldn't see it directly, threading through our solar system on a trajectory that has a combined probability of 0.005%. When telescopes at Lowell Observatory locked onto C-2024, G3 Atlas rising above the northeastern horizon, they captured more than just another comet. Belgian and American researchers discovered its surface is covered with something unprecedented, a 15 to 20 meter thick crust of organic compounds forged not in its home star system, but during 3 to 11 billion years drifting through the galaxy. Galactic cosmic rays, particles accelerated by supernovae and colliding black holes, have been bombarding this wanderer since before our solar system even formed. These high-energy particles penetrated deep, breaking apart molecules, creating complex carbon chains, then destroying them again in a cosmic forge running continuously for eons. But here's where conventional explanations start breaking down. The composition analysis reveals carbon dioxide emissions 7.6 times more abundant than water. Comets are supposed to be dirty snowballs, primarily water ice. This one barely qualifies at just 4% water by mass. The spectral signature shows elevated carbon monoxide and an unusually red reflection spectrum from organic molecules coating the surface. Then there's the nickel-to-iron ratio matching industrial alloys, not natural cosmic dust. The nickel-to-cyanide ratio is orders of magnitude higher than every known comet, including 2I Borisov, our previous interstellar visitor. Some researchers are putting the probability of these characteristics occurring naturally at less than 1%. The polarization measurements shattered expectations. Extreme negative polarization, unprecedented for any comet ever observed. Not just unusual, but statistically anomalous when compared to the entire catalog of cometary data. When light bounces off the dust and gas around Atlas, it behaves in ways that conventional models can't explain. And the trajectory reads like something planned. A retrograde orbit aligned within 5 degrees of the ecliptic plane, threading through the solar system with a statistical likelihood of just 2%. It passed within tens of millions of kilometers of Mars, Venus, and Jupiter, arriving at perihelion on October 29th when Earth couldn't observe it directly. During July and August, observers documented something that challenged basic physics, an anti-tail pointing directly toward the sun. Not an optical illusion created by perspective like familiar comets display, but an actual jet of material shooting in the wrong direction. The papers are published, the data is solid, but the mechanism remains unexplained. Then, as Atlas approached perihelion, space-based solar observatories captured rapid brightening beyond any known comet behavior. The object became bluer than the sun itself. Think about that. A supposed ball of ice and dust outshining our star in certain wavelengths. Stereo, SOHO, and GOES satellites all recorded the same phenomenon. The close passage near the sun created a perfect natural laboratory for testing Einstein's general relativity. Gravitational lensing calculations show the sun's gravity should deflect light from Atlas by 27 arcseconds. The Atacama Large Array detected the comet 4 arcseconds away from its predicted position near perihelion. Some of that deviation could be gravitational lensing, but there's another explanation: non-gravitational acceleration. The comet changed velocity without any obvious gravitational cause. If it's outgassing, if jets of sublimating ice are pushing it around like a natural rocket, then it should have lost at least 15% of its mass. That's over 5 billion tons of gas and debris, a massive cloud that should be impossible to miss. Observations continuing through November and December will either confirm this cloud exists or we'll have a 10th anomaly to explain. The organic crust theory solves some mysteries while creating others. If radiation processing altered the surface to a depth of 20 meters over billions of years, we're not seeing primordial material from another star system. We're analyzing radiation-processed remnants. It's like trying to read a book that's been left out in the sun for 3 billion years. The words are still there, but they're not the original text. Which brings up an uncomfortable question. How do we study the origin of an interstellar object when its surface has been fundamentally transformed? Some researchers are proposing alternative interpretations. What if the anomalies aren't separate coincidences? What if they're connected by something we haven't considered? The alignment with the famous WOW signal direction within 9 degrees. The trajectory optimization for planetary flybys while avoiding easy Earth observation. The industrial metal ratios, the unusual polarization, the unprecedented brightening. Each one individually explainable if you really want to explain it. But together, 9 confirmed anomalies, possibly 10 depending on what the next observations reveal. At some point you run out of statistical wiggle room. The scientific community is watching December 19th with particular attention. That's when Atlas makes its closest approach to Earth at roughly 0.4 astronomical units, close enough for unprecedented observational opportunities. Every major telescope that can point at it will be collecting data. Spectroscopy, photometry, polarimetry, radar, if the geometry works out. This is our chance to gather evidence that might not come again for decades. Qichuan Zhang from Lowell Observatory demonstrated something remarkable using just a 6-inch amateur telescope, capturing Atlas when it was only 16 degrees from the sun, 5 degrees above the horizon during morning twilight. The implications are staggering. Every interstellar object we detect might be wearing a mask of radiation-processed material. The surfaces we analyze, the spectra we measure, they're telling us about the journey through space, not necessarily about the origin. But the math doesn't quite work for a purely natural explanation of all the observations together. Take the trajectory alone, flying retrograde, nearly aligned with the ecliptic, arriving precisely when multiple planets are in range, while Earth has no direct line of sight. Add the composition anomalies, and each one stretches credibility. Stack them together, and you're either witnessing the cosmic equivalent of winning the lottery 9 times in a row, or something else is happening. The radiation processing theory explains the organic crust and the carbon dioxide dominance, but it doesn't explain the nickel enrichment. It doesn't explain the trajectory. It doesn't explain the anti-tail dynamics. And it certainly doesn't explain why the comet brightened beyond known limits and turned bluer than the sun at perihelion. Some scientists are starting to whisper about what they're not saying publicly. The data is solid. The observations are repeatable. The anomalies are documented. But the conclusions that logically follow from the data lead to uncomfortable places. Radio telescopes maintained observations throughout the perihelion passage, while optical telescopes lost sight of Atlas against the sun's glare. Radio wavelengths penetrated through. If the upcoming observations don't reveal that 5 billion-ton debris field, we need a new category of explanations. The amateur astronomy community is mobilizing worldwide. Professional observers are coordinating multi-wavelength campaigns. Universities are rushing to allocate telescope time. This is what astronomy looks like when something genuinely unexpected shows up. We've studied exactly 3 confirmed interstellar objects: Oumuamua, Borisov, and now Atlas. That's not a statistically significant sample. We don't actually know what's normal for objects from other star systems. But here's what we know for certain. Atlas is real, it's interstellar, and it's displaying behaviors that push the boundaries of established comet science. The question isn't whether the data is accurate. Multiple independent observatories using different instruments and techniques have confirmed the measurements. The question is what framework we use to interpret that data. Consider what it would mean if this isn't natural. Confirmation that we're not alone. Proof that interstellar travel is achievable. Evidence that other civilizations exist and are actively exploring. The philosophical implications would be staggering, but we're not there yet. The data is ambiguous. Natural explanations remain possible, even if increasingly contrived. Extraordinary claims require extraordinary evidence, and while the evidence is certainly unusual, it hasn't crossed the threshold to extraordinary. This is where the conversation gets dangerous for careers. Suggesting the possibility of artificial origin invites immediate criticism. But the data doesn't definitively prove natural origin either. At some point, when enough anomalies accumulate, refusing to consider all possibilities becomes unscientific. Behind the careful language, there's an awareness that something genuinely strange is happening. We're supposed to argue about ambiguous data. That's how knowledge advances. For now, Atlas moves through our solar system, a traveler from distant reaches carrying mysteries we're only beginning to understand. Every photon it reflects tells part of the story. Every molecule it releases adds to the narrative. Every measurement brings us closer to truth, whatever that truth turns out to be. December approaches. Telescopes are ready. The world watches and wonders. We're witnessing something rare and possibly unique. An object from another star system displaying behaviors we struggle to explain, offering mysteries we're only beginning to unravel. The questions outnumber answers. The uncertainties outnumber certainties. That's how discovery works. Uncomfortable ambiguity means we're at the frontier, pushing into territory nobody has mapped before. Atlas brought us to that frontier. Where we go from here depends on what we find next and whether we're brave enough to follow the evidence wherever it leads.